Okay, we're streaming now. All right, so let's look at this question 8 on practice quiz 5. So let me just rewrite the question, and you guys should all have the quiz 5 available on Canvas. All right, so what is your question about this problem?
I was just gonna ask if you could just go through it and see if I did the same thing you did.
Okay, sure. So for the first part, it asks like, what is the probability of the user winning the series? So for this question, we want to use, so we know there should be different cases where, since it's a best of 5 series, then what's going to be our cases?
They could win 3 in a row. They could play 4 and win the last one, and then play 5 and win the last one.
Yep. So basically, let's write our first case. And then the probability of just win all the first 3. And then this one should be straightforward, which we know that the probability of wins a single game is 2/3. Then for this one, we'll just take 2/3 cubed. And that's 8/27. And for our case 2, it's going to be that the probability of so we want to make sure it wins the last game. So all we want to do is that for the first 3, we need to choose 2 spots, and then because we know that it has to win the last game. So we want to use 3 choose 2 to pick the first 2. And then we know we're going to do 3 cubed squared, 3/3 cubed, and then times 1/3. And then this should give us 8/27. And here our case 2 is we have a total of 5 games. And then now we wanted to pick 2 from the first 4. So we just choose 2. And then we know it already went like 3/3 cubed and then times 1/3 squared. So we're guaranteed to win the last game, and then we also want to pick 2 from the first 4. And this one gave us 16/81.
I have a quick question.
Uh-huh.
Where does the 2/3 squared and the 1/3, or I guess 2/3 cubed and 1/3 squared come from?
Yeah, so the 2/3 is like the probability you win a single game. And then for case 2, it's like we're gonna play total of 4 games. And then we know like it's guaranteed it has to win the last game. So the only thing we didn't know is like which 2 to pick from the first 3. That's why we have the 3 choose 2. So if we pick this 2 from the first 3, then so this you can think about this like 2/3 and then 2/3 and then the single game that it didn't win should be 1/3. And that's how the 3/3 cubed times 1/3 come from.
Oh, okay, gotcha. Cool, thanks.
Yeah, and similar for case 3, you're guaranteed to have the last game. You have to win the last game, and then it's similar for the other 4, which probably you want to pick this 3. Oops, it should be. So like probably pick this 2. And then you're gonna lose the other 2. All right, and the probability of winning the series would just be using the rule of sum, which add all these 3 cases together. Any other questions so far? All right, so let's look at part B. It says, what is the average number of games needed to decide the series with either team winning? All right, so it asks like the average number of games. So basically, you need to think about the expected value. So we know that in our so in terms of like the average number of games, we know there should be different cases where your x represent the number of games played to decide the series. So similar as like the part A. You should also have 3 cases where when your number of games should be can be 3 or it can be 4 or 5. And then for keeping the expectation, you just take 3 times whatever you have the probability when x equal to 3 and plus 4 times probability when x equal to 4 and plus 5 times the probability when x equal to 5. All right, so let's take a look at the probability when the number of games is 3. So you need to count on both sides where so we know like one team wins the game has a probability of 2/3 and the other team has a probability of 1/3. So if our number of games is 3, then we should have 2/3 cubed plus 1/3 cubed. All right, and this should give you 1/3.
So that term inside of the parentheses, is that saying the probability that we get 3 games only?
Yeah, so that's what the x equals to 3 means. Like the number of games is 3. So if the number of games is 3, then if a team wants to win, it has to win all three games.
Okay, all right, that makes sense.
Yeah, and then so let's think about x equal to 4. How would you write this this probability? So you still need to think about like two teams where it's like we're using like the similar idea as you did in part A, where you think about, okay, so if we have 4 games total, and if one team wants to win the series, it is guaranteed that the team has to win the last game. Right, so if you think about like the team has a probability winning the single game is 2/3, and then we know that like right here, like last spot has to be 2/3, and then now we have 3 spots left. So we basically wanted to similar to just do 3 choose 2, where you want to just pick the 2 games that your team win, which can be probably like 3/3, and then the third game you lose. You lost the third game. So this is just one of the possibilities. So in terms of that, you still need to do 3 choose 2 times 2/3 cubed times 1/3. All right, and that's only for the team that has a probability of 2/3. Instead of raising it to the power of 3, raise it to the power of 4. Are you talking about the this case? Okay. Yeah. So for the other team, which has a probability winning a single game is 1/3. As always, won the last game. We want the team to win the last game. So I'm just list like one of the possibilities where you're still gonna do 3 choose 2 and then times 1 cubed, 1/3 cubed, sorry, and times 2/3. All right, and that should give you the probability when x equal to 4. And I believe that's equal to 10/27. All right, so now the probability of x equal to 5. So for this one, just follow the same strategy. Now we have 5 games. And then instead of 3 choose 2, now we want to do 4 choose 2. Or like just pick any of the 2. And then now we should have 3/3 cubed and then times 1/3 squared. So now you see like the sum of the like exponents right here should equals to your number of games, right? Like 3 plus 2 should equal to 5. And right here, your 3 plus that's actually 1/3 to the power of 1. It's actually equal to 4. And then right here you have 3 and 3. So for the other game or other team to win the game, you have probably 1/3, and if you just like randomly pick 2, and then that's so for the total possibility should be 4 choose 2 times 1/3 cubed times 2/3 squared. All right, and this should give you right here. So this should give you 8/27. All right, and now you have all of this. Now you have these 3 probabilities where you can just directly substitute in the your expectation formula. Questions? So okay, so why is always choose 2? Because in like a best of 5 series, we if a team wins the game, it has to win like 3 games. So whichever the team like first to win 3 games, then the team wins. So why is it choose 2? Because because that team has to win the last game in a series. Yeah, so that's why we now have 2 other games left to choose from, the previous 4 or previous 3. All right, so that's question 8. I think I saw like problem 3 on homework 6. Yeah, we can go over that one. So let me pull out the homework first. All right, so okay, so problem 3. All right, so this one is a challenging one, so let's take a look at this one together. All right, so you're playing blackjack and want to know like the probability of getting down certain cards. So the first is down to you face down, and the second is down face up. And we want to find the probability that the bottom card is in ace or a king, and the top card is red. All right, so let's look at part A first. And then after we finish part A, you should have pretty good clue on how to solve part B and C. So just by looking at the question asking, like, found the probability that the bottom card is an ace or a king and the top card is red. How would you define your events? And how would you like start set up your probability?
I would set up my events as all possible pairs of cards I could get, where the first card in an ordered list is the bottom and the second is the top card I draw.
Yeah, so basically 2 events. So where your event A is your first card or your bottom card, and your E2 represents the top card. So let's start the definition where let E1 be the event that the first card is an ace or a king. And let E2 be the event that the second card or the next card is red. All right, and how would you want to write the probability?
Wouldn't there be like 2 different cases? Because the king and the ace could be either red or black.
Yeah, so there are actually 2 different cases. I guess there are like multiple ways to solve this question. I'm just using the one like where we start from like E1 and E2. And then inside of right here, we will actually deal with 2 cases inside of the in our calculation rather than just separate them into 2 cases. But yeah.
Okay.
Yeah, so this one it's like the probability of E1 and E2. And then how would you write the rest part? Or like how would you write the your right hand side? Or just let me ask another question. So are E1 and E2 independent or dependent?
Dependent.
Yep, so they are dependent. How would you write the probability where your E1 and E2 are dependent? Like how would you write that?
So wouldn't you have like the first term being probably like the first term be the probability of it being an ace or a king, and the second term, well, times the second term where it's the conditional probability, like
Yeah, exactly.
on what color it is.
Yeah. So basically on the right hand side, it should be E1, the probability of E1 times the probability of E2 given E1. Right? Because E1 is our first card and E2 is our second card. So the probability of getting a second card is a red depends on the like the outcome of your of what cards you dealt as the first card. All right, so now let's take a look at the probability of E1. So just think about this as a single event, and then how would you write the probability of E1? So just by applying the definition of the probability. Is the number of possibilities of E1 happens over the sample space. And what's going to be your number of possibilities of E1?
It would be 8.
Yep, will be 8. Do you want to explain like how you get 8?
Oh, because you have 4 suits and you have 2 choices. So each card can be one of 4 suits.
Yep, exactly. So the number of possibilities of E1 would just be 8. And then what about the sample space?
Would it be 52 times 51? Because you would have 52 choices for the first card, the pair, and then 51 choices for the next card.
So right here, think about the probability of E1, just only a single. Think about only E1 happens. So right here, we're not we don't care about like your event E2. So right now, it's basically just treats probability of E1 as like just a single event. So we don't care about E2 right now. So it would just be 52. But on the second part, you do need to care about E2. So, all right, so just think about like the probability of E2 given E1. And what is the how would you write like the conditional probability? What does the probability of E1 given, sorry, what does the probability of E2 given E1 equals to?
Wouldn't it be the size of the set given by the intersection from the 2 events?
Yep, exactly. Or feel like that's confusing. Oh, oops. It should be equal to this. And then so right now at this point, right here, the numerator, we actually do have like the where you wanted to have 2 different cases, where think about the number of possibilities that event E1 and E2 happened at the same time, where what's going to be our two cases here?
So like one case would be if the card we picked first was black, and then the second case is if it was red.
Yep, exactly. So the first case would be if the first ace or king is black. And then the second case would be if the first ace or king is red. All right, and let's think about the case where if the first ace or king is black. If the first ace or king is black, then how many possibilities are there to draw the first card?
Still 52 choices, right? Well, no, 51.
Well, like how many possibilities that the first card is ace or king, and the first ace or king is black. So that one will just be 4, right? And then the second card, where is a red card, which should be 26. So which you have like 4, well, it should be 4 times 26. Where the second case, like the first ace or king is red. And then if it's red, we still have like 4 cases in times where you have the second card is a red, and now you already pick a red card as your first card. So now you have 25 left. And then like on the denominator, now it's what we have like for the bottom card is an ace or king. And then the next card is red. Or sorry, so let me see. So number of possibilities of E1. When you actually want to draw 2 cards, so it should be your event. It should be E1 times whichever the possibilities left. So we know that E1. So we know that the number of possibilities of E1 is 8. We have like 8 possibilities to actually have a card that is an ace or king. Right, I already like figured that out like at this part. And then we don't actually care about if the second card is red or black. So now we're gonna have 51 card left to choose from. That's gonna be your N of E1. All right, so and the result of this computation should give you the answer of probability of E1 and E2. And I believe that's, what is it? $113. And then like remember I said there's other ways to solve this problem. And so we actually like treat the different cases right here, but like just there are just students just like we could actually have like different cases at the beginning where it's just like a different setups. You could say like E1A be the event that the first card is an ace, and the E1B be the event that is a king. The first card is a king, and your E2 is still going to be the event that the second card is red. All right, and then it's just going to be the slightly different setups. So you still want a E1 and E2. And then now your setup should become the probability of E1A, which is the first card is an ace, times the conditional probability E2 given E1A. That's like your first case, case 1. And then plus the probability of E1B, which the first card is a king, and then times a conditional probability E2 given E1B. That's your case 2. So these are two different ways to solve the problem, but yeah. Both of them should give you the same answer. And that's question 3, part A. Any questions so far?
Can we do 5 part C from the homework?
Sure. Question 5, part C. Let me read the question first. All right, so we're basically given 3 different probabilities, like 1/3, 1/6, and 1/2. And then it's asking like, what is the probability that in 3 holes the golfer gets a pair more times than they get a hole in one? Okay, so I know nothing about the golf game, but since we have the probabilities and we see the word like more times then, so you know we're probably gonna use different cases here. So, let me see. All right, so let's just consider like all the possible combinations. So let's just use different variables to represent that. All right, so now like in three, so now we'll basically turn the problem into that your H plus P plus A equals to 3. Right? Because you're computing the probability that in 3 holes. And then we have another restriction that we want to make sure that our P is greater than H. All right. And now, what are the cases right now in terms of the number choice of P, H, and A?
So don't we have, if there's 0 hole-in-ones, then there has to be like at least 1 par, and then if there's 1 hole-in-one, there has to be 2 par.
Mm-hmm. So, yep, case 1. If it's if your P is 1, so if your P is 1, then there should be only one combination, right? Like 1 par, and since you want like your hole to less than par, then it should be 0 H, and then 2A, or 2 anything else, right? Like that's the only combination for when your P equal to 1. So where the second case, when your P equals 2, which you have 2 pars, what are the possible combinations? What can be the possible combinations? So 2P, and then you can either have 1H or 0H. So if it's 1H, then you should have 0 anything else, and or if it's 0H, it should be 1A. And that's your two combinations for case 2. Which you know that you're probably going to use rule of sum somewhere in your case 2 computation. All right, and then let's take a look at case 3. When you have 3 parts, your P equals 3. And this one should give you the only combination where, because you have 3 holes. So 3P, 0H, and 0A. All right, and now your job is to compute each of the. You need to compute the probability of each combination, and then just add them together. All right, so let's just take a look at 1P, 0H, and 2A, this case. Let's just denote this as E1. Still think them as 3 spots. So how would you choose your 1 part? All right, so I guess think about this as you have 3 spots that need to be occupied. And then what you can do is that just pick 1 out of 3 to place your P. And then the rest 2 is going to be your to anything else. And then you also need to times their probabilities, which if you want to choose 1 part, well, I say I'll probably choose this one. And then think about the probability of getting a part, which is 1/6, I believe. And then, you know, the other 2 is anything else. So that 1/2 and 1/2. So that is one of the possibilities of your event E1. So how many ways you can place this 3 numbers?
Three.
Yeah. And that's like the same as 3 choose 1. Right. So there are 3 choose 1 ways, or 3 ways to place this numbers. So you want to do 3 times 1/6 times 1/2 squared. And that's your probability of E1. And this is equal to 1/8. So now our case 2, if I just know that at E2, and then I'm just going to use the rule of sum to add those combinations together. And then still think of them at 3 spots. And now you have, and now instead of one per, one part. You want to have two parts. I'm writing here is one of the possibilities. And then how many possibilities total are there to choose this to have this combination?
Is it 3 again?
Yeah, it is 3 again. So you can write it as 3, 2, or it is the same thing in a 3, 1. And for the other combination, so right here, this case is actually 2p, 0h, and 1a. So for the other case, should be we wanted to have the case where it's 2p, 1h, and 0a, which is still going to be 3 choose 2, which is 3, and then times 1 6 squared, and then times what is the property of getting a whole? 1/3. Okay. And then that's our property of E2. And that's 5/72. And for case 3, this one should be straightforward. You know that there's only one combination, 1 6 cubed, and that's 1/216. All right, and then you just wanted the event E. You just want to add all the probabilities together to cover all cases. And I think this should give you 43/216. All right, any question? Okay, then
I got a quick question, my bad.
yeah, go ahead.
For case 2, to get the total probability for that, you would add the individual cases together within that term.
So think about them as two different combinations where you can have 2p, 1h, 0a, or 2p, 0h, and 1a. So that's under the case when you have two parts. So you want to use rule of sum.
Right. Okay.
Yeah. Did I answer your question?
Yeah. Thank you.
Okay. All right. So if there's no other question, this is just going to be our end of review of quiz 5 review. And you're free to go.
Okay, thank you.
Good luck on quiz